Good day, viewers. Welcome to today's class. So, I'm your teacher, Choma, teaching you mathematics. So, today, we're going to continue from where we stopped in our last class. That's addition and subtraction of number base. Okay, so like I said, we're going to be doing the correction of the previous class before we start today's class. So question number 1 was convert 212 base 3 to base 10. So we do this conversion using expansion method. So we have 212 base 3 is equals to, so what you do is multiply each of the numbers using the base one after the other. So we have 2 times 3, that's this 2 times the 3, which is the base, plus this 1 times 3, which is also the base, then times this last 2 times 3. Okay, so after you multiply the numbers one after the other with the base, you add your powers, starting from the last one with 0, here will be 1, here is 2. Okay, so we continue with the expansion. So this is 2 times 3 raised to the power of 2 is 3 times 3, which is what? 9. So we have 2 times 9 here, plus 1 times 3 raised to the power of 1 is 3, plus 2 times 3 raised to the power of 0 is 1. I've said that before. Any number raised to the power of 0, the answer is 1. Okay, so we have equals to 2 times 9 is 18, plus 1 times 3 is 3, plus 2 times 1 is what? 2. Okay, so if we add everything together, this 18, 18 plus 3 is 21, 21 plus 2 will give us 23. So our answer is 23 base 10. To say therefore, 212 base 3 is equals to 23 base 10. So this is the answer for the first assignment, okay, in our previous class. Okay, so just go through it and correct yourself in case if you solved it and you make the mistake. From here you can check and correct your mistakes. Okay, so let's go to the second question, which is convert okay, so question 2 says convert 1023 base 4 to base 10. Okay, the solution, so I have 1023 base 4 is equals to, so just like what we've been doing, we multiply the numbers one after the other with the base. So we have the first one is 1 times 4 plus 0 times 4 plus 2 times 4 plus the last 3 times 4. Okay, so the next thing is to put our powers of the base starting from 0, 1, 2, and 3. Okay, so we have, this is 1 times 4 raised to the power of 3 means 4 times 4 times 4. 4 times 4 is 16, that is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So we have 64 here, plus 0 times 4 raised to the power of 2 is like cleaning one of the 4, which is 4 times 4. That will give us 16. So we have 0 times 16 plus 2 times 4 raised to the power of 1. That's just 1 4. And you have 4 here, plus 3 times 4 raised to the power of 0 is 1. Okay, so let's continue. 1 times 64 will give us 64, plus 0 times 16 is 0. Anything multiplied by 0 will give you 0. Okay, plus 2 times 4 is 8, plus 3 times 1 is 3. Okay, so let's add everything together. We have 64 plus 8 plus 3. 8 plus 3 will give us 11. So let's do a little addition here. This is 64. 8 plus 3 is 11. So when we add it together, we have 75. So our answer is 75 base 10. So say therefore 1023 base 4 is equals to 75 base 10. So this is the correction for our previous class assignment. So check it very well and do your correction. So with this, we're done with the correction. So we now move to today's topic, which is addition and subtraction of number base. So today's topic is addition and subtraction of number base. Addition and subtraction of number base. Okay, so before we start our solving, excuse me, before we start our solving, addition and subtraction of number base is not like normal addition of numbers. Okay, the way we do normal addition of numbers is not the way we do addition of number base, because you are always working with base. So when you are adding numbers, two numbers, and you are working with a particular base, it is the base that determines your answer. For instance, if you are working with the base 5, your answers that you are going to get must not be up to 5. Okay, by the time we start solving, you understand better. I just want to give you a little introduction on how it's going to look like. So it's not going to be like normal addition. Okay, so let's take some examples so that we understand what we're doing. So say first example says calculate example 1. Say calculate 314 plus 24 in base 5. Okay, calculate 314 plus 24 in base 5. Okay, so you arrange it in this form. Solution, write your 3, 1, 4 and 2, 2, 4. Okay, you put your addition sign, you rule 3, 1, 4 plus 2, 4. Okay, now, so like what I was explaining, whatever you're going to add here, your answer must not be up to 5, because you are working in base 5. So it is the base that tells us what to write here. Now, if for instance you add two answers, two numbers together, and you are having more than 5, it means you are going to subtract that 5, which is the base, from the number. Now it is the remainder, that is what you write here as your answer. While the one you subtracted, you carry it to this other side as 1. Now what do I mean by that? The first thing we are going to add is 4 plus 4. Okay, so let's put our solving here. We have 4 plus 4. Our answer is what? 8. Now this 8, you can't write 8 here because 8 is bigger than 5. Any answer you're going to write here must not be a number that is bigger than 5. Okay, because you are working in base 5. So if you have 8, what you ask yourself is, okay, since 8 is bigger than 5, then we have to subtract 5, which is the base, from 8. So we have 8 minus 5, and our answer is what? 3. So is this 3? That's what you write here. Okay, then this minus 5 you subtracted, you carry it as 1 to the next part. I believe I'm understood. Okay, I will still go through it again. So we now have 2 plus 1 is 3, plus the one you carry from this side, making it what? 4. Good. 4 is a number that is less than 5, so you can write 4 here. And lastly, this is 3. There is no number here, so you bring down the 3. So our answer is 343 base 5. So let me just go through it again one more time. We are adding 314 plus 24 in base 5. Assuming it's normal addition, you will just have your 8, have your 3, and have your 3. But no, we are working in base 5. So it's not like normal addition. Okay? So if you are working in any base, your answer must not be more than the base. Okay, so here the first two numbers we are having here is what? 4 plus 4. 4 plus 4 is what? 8. 8 is bigger than the base you are working with. So you have to subtract the base. we are working with from that 8. And that's what we did here. 8 minus 5. But our answer is what? 3. When you subtract 5 from 8, you get 3. It is this 3. That's what you write as your answer here. Then this minus 5 you subtracted, you carry it as 1 to the next part. Okay, and you now add. So here 1 plus this 2 will give us 3, plus the one you carried from this 5. Add it to it, it becomes 4. Now you can write 4 because 4 is less than the base, so you can write it down. And here there is no number here, so you just bring down your 3. Okay, so the major thing is just know that anytime you are adding or subtracting, once your answer is bigger than the base, you have to subtract the base from the answer and write your remainder. And remember to carry how many times you subtracted the base to the other side. I believe this example 1 is understood. Okay, so let's go to example 2. So example 2, let's do with a binary number. Say evaluate 1011 plus 1011. Now you are going to be like, just like what I said in the other class, anytime you see number like this, we are talking towards binary number. It's all about binary number. And binary numbers are in base what? 2. So this is base 2. So the base we are working with is base 2. Okay. Solution. So here we have 1011, 1011. Put your addition sign, you roll. Okay. Now in binary, normally binary as a whole is a different topic on its own. Okay. Now when we are adding binary numbers, in binary numbers, 1 plus 1 is 10, not 2. 1 plus 1 is 10 in binary, not 2, like your normal addition. Okay, so this 1 plus 1 is not going to give us 2, rather it's going to give us 10. That is the law of binary. Binary, we are coming to binary, is a whole topic on its own. Okay, but just for now, just know that 1 plus 1 is equals to what? 10. That is applicable in binary. Okay, so if you have 10, what will you write here? You write 0, carry what? 1. Now you come here, 1 plus 1 again is another 10. Plus the one you carry from here will give you 11. Okay, so we write, that's 1 plus 1 plus 1. The answer is what? 11. You write 1, carry 1 to this other side. This 0 plus 0, 0 plus the one you carry, you have 1. Then this last one, 1 plus 1 is what? 10. So our answer is 10110 base 2. Okay, let me recap it again. Now, I know this may look a little bit confusing, but you don't have to be confused. Just know that in binary numbers, 1 plus 1, the answer is 10, not 2. Okay? 1 plus 1, the answer is 10, not 2. So when you have this 1 plus this one, you get 10. That's why I'm bringing down the 7 here so that you understand better what we are doing. So 1 plus 1 will give us 10. So you write 0, this 0, and carry this 1 to the next part. Okay? So that next part will now be this 1 plus this 1 plus the one you carry from here. That's 1 in 3 places, which is 1 plus 1 plus 1, which is equals to what? 11. Okay, so this 11 you write 1, carry 1 again to the other one, and that will give us 0 plus 0 plus 1. Okay, 0 plus 0 plus 1, that is equals to what? 1. So that's this one you are seeing here. And lastly, 1 plus 1 is 10, just like this first one. Okay, so that is that for this question. Now, I know some students will be kind of, how is it like that? Good. Now, if you check the numbers we are seeing here, there is no number that is up to 2. All of them, when it comes to binary, anything binary number, just like the definition of binary number is numbers that comprises of 0 and 1. That's the definition of binary. So anytime we are dealing with binary numbers, The only answer you are permitted to have is 0 and 1, 0 and 1. There is nothing more than that. Okay? That is why 1 plus 1 is giving us 10 instead of 2 as a normal addition, because we are dealing with what? Binary. I hope that is understood. Okay, so let's go to example 3. Example 3, we are going to be looking at subtraction. We're going to be looking at subtraction of number base. Okay, so we have subtraction. Say, calculate, example 3, calculate 5117 minus 324 in base 8. Base 8. Calculate 5117 minus 324 in base what? 8. Okay, so solution, we arrange it as usual. 5117 minus 324. Okay. Alright, so just like what we did in addition, is also applicable to what? Subtraction here. Now, you agree with me that in subtraction, in a normal subtraction of numbers, if you want to subtract a bigger number from a smaller number, which cannot be possible, you have to borrow, right? That's in a normal addition of numbers. But in this case now, if we come across that scenario, that borrow that we're going to borrow is going to be the base that we are borrowing. In a normal subtraction of number, when you are borrowing, you borrow as 10. Okay? But in this case, when you are borrowing, you borrow it as what? 8. Because you are working in base 8. I believe we are okay with that. Okay. So this first one is saying 7 minus 4. Normally, 7 is bigger than 4, so that one is okay. 7 minus 4 is normally 3. Our answer is 3. Okay. Now, this next one is 1 minus 2, which is not possible because 2 is bigger than 1. So that is where the borrowing comes in. Are you with me now? So 1 minus 2 cannot go. So you have to borrow this 1, add to this 1, so that you'll be able to subtract it from the 2. Okay, and this one we are borrowing, we are not borrowing it as 1, we are borrowing it as the base, which is 8. Okay, so if we are borrowing this one, say this one here plus 8. So once you have borrowed this one and add to this one to give you the 8, then remember that here is now 0. In case when you come to this section, know that here is now 0 because you have borrowed this one to add to this one. And that one you are borrowing, you borrow it as the base, which is 8. So it will now be 1 plus 8, which is what? 9. So it is now 9 minus 2 that you calculate here, which is giving us what? 7. Okay? So 9 minus 2 is what? 7. So remember you borrowed this one out, so here is 0. Now, when you come here now, 0 minus 3 is not also possible because 3 is bigger than 0. So you have to borrow again from this 5. Add to the 0 here. And remember, when you are borrowing, it is the base you are borrowing, which is 8. So when you borrow 1 from here, add here, it will become 8 because there is no number here again. You have already borrowed this one out. So here it was remaining 0. So when you borrow 8 plus 0 will give you what? 8. So you have 8 minus 3, which will give us what? 5. I believe we are together. So when you have 5 here, now what is remaining here? 4, because you borrowed 1 out. Okay, so let me just go through it again. Alright, so let me explain it in details before we start. If during subtraction of number base, you borrow, when the number that you want to subtract from is bigger than the number you are subtracting, you borrow. On a normal subtraction of numbers, the borrowing, you take it as 10 and add to the other number so that you can be able to subtract. But in this case, what you are borrowing, you take it as the base, which is 8, the base you are working with. Okay, so this first one, we are not borrowing because 7 is bigger than 4. 7 minus 4 will give us 3. That one, there is no issue there. Now, this one is 1, and this is 2. 2 is bigger than 1, so this is when the borrowing comes in, okay? So we have to borrow this one, add to this one. Now, this one we are borrowing, we are not borrowing it as 1, rather we are borrowing it as 8, which is the base. And that's why we are having 1 plus 8 to give us what? 9. When we borrow this one, add to this one, it becomes 8 plus this one, which is what? 9. Then 9 minus 2. Maybe I should write it here, 8 plus 1, which is what? 9. 9 minus 2, that will give us 7. Okay? Now, what is remaining here? 0. Okay? So this 0 now, minus 3 is not also possible. So you still have to borrow again. So borrowing from this 5, add to the 0. Remember, the borrowing is the 8. So you have what? 8 plus 0. So it will be 8 plus 0, which is what? The same thing as 8. Minus this 3, that will give us what? 5, which is what you have here. And lastly, we removed 1 from here. So it's remaining 4. So our answer is 4, 5, 7, 3, base what? Base 2. So this is our answer for example 3. Alright.
Original base 8.
Oh, sorry. Base 8. Thank you for that.
We talk about the answer here.
Okay, so our answer to this question is 4, 5, 7, 3, base 8. Alright, so that's the answer for example 3. Let's take another example under subtraction. Okay, this is example 4 now. Say evaluate 321 minus 113 base 5. Solution. Okay, 321 minus 113 base 5. 321 minus 113 is 5. Okay, so let's start. So remember that when you're subtracting a number that is bigger than the one up, you borrow. And what you are borrowing is the base. Okay, don't forget that. Okay, so this is 1 minus 3, which is not possible. 3 is bigger than 1, so we are going to borrow. Okay, we are going to borrow 1 from these 2. And that one we are borrowing is what? 5, because we are working in base 5. So when we borrow it, it will now be what? 1 plus 5, which is what? 6. So it will now be 6 minus this 3. The answer is what? 3. So it's 3 that we'll have here. So what is remaining here? 1, because we have already borrowed 1 out. So 1 is remaining here. So 1 plus minus 1, that will give us what? 0. And this is 3 minus 1 is what? 2. So our answer is 203 base 5. 203 base 5. Okay, let's go through it again. We are subtracting 113 from 321. You arrange it in the normal way, then you subtract. 3 minus 1 cannot, because 3 is bigger than 1. So when you do, you borrow. You borrow from this 2 to add to the 1, and the one you're borrowing is regarded, it is 1 you are borrowing, but it is regarded as 5, which is the base. So you borrow the 1 out and add it here, which is 5. That will now give you 1 plus 5, which is 6. So it will now be 6 minus 3, which is this 3 we are seeing here. Then what is remaining here? 1, because we have borrowed 1 out. So it's 1 that is remaining. Let's go to example 5 now. So this one we are going to be looking at subtraction of number base under binary numbers. Okay. So we have evaluate. This is example 5 now. Evaluate 1101 1101 minus 11 base what? 2. Even without being told, you should be able to know that binary number is base 2. Okay, so let's solve. The solution, we have 1101 minus 11. Roll. Okay. Now, in subtraction of binary 2, normally 1 minus 1 is 1. Then in this one, when you are borrowing as what? 10. Okay? Just like this. This 0, now when we get to this place, if we are borrowing, it's going to be 10 that we are borrowing. Okay? Alright. So the first one is 1 minus 1 is normal. The answer is what? 0. Okay? Then 0 minus 1, that's where the borrowing comes in. Okay? Because 0 is smaller than 1. So you have to borrow 1 from here, add to 0 to make it what? 10. So it will be 10 minus 1, which is what? 1. You agree with me that when we're doing addition of binary, we said 1 plus 1, the answer is 10. So 10 minus 1, the answer should be 1. Okay? Just like bringing this to this other side, 10 minus 1. So if 1 plus 1 is 10, 10 minus 1 should be what? 1. Okay, so remember we have borrowed this out to add to this 0 to make it 10. So there is nothing remaining here. So here is 0. So you bring down 0 here. And also this one, there is nothing here. So you bring the 1 down. So our answer is 1, 0, 1, 0. Okay, let me go through it again. This is 1 minus 1, normal. 1 minus 1, the answer is 0. Then this is 0 minus 1, which is not possible. You have to borrow. Okay? And when you're borrowing, remember the previous example that we did, I said when you are borrowing, you borrow the base. But in this case, I know the base we are working with is 2. But this is binary number. Anything we are dealing with should be between 0 and 1. It's not more than 0 and 1. You can't get 2 here or 3. 0 and 1. Okay, that's what we are working with. So the one you are borrowing, you borrow it as what? 10. And add to this 0 to give you 10. So you have 10 minus 1. The answer will be what? 1. Alright? So when we have this, we have the 1, 10 minus 1, the answer is 1. Then here, remember you have borrowed this one out. So what is remaining is 0. So that's what we brought down here. And this last one is this because there is nothing here to subtract from. So our answer is 1, 0, 1, 0 is 2. Alright, so this is our example 5. Now let's take two more examples under addition that is a bit complex. Okay. Alright, so let's take example 6. Okay, so this example 6 is under addition, but we're going to be having 3 sets of numbers. Okay, so calculate 421 plus 12 plus 42 in base 5. Okay, so you agree with me that we have been dealing with 2 sets of numbers, but this one is 3 sets. Okay, so we have solution. We have 421 plus 12 plus what? 42. You roll. Okay, so we are working in base 5, remember. So you do your addition. So this is 1 plus 2, 3, 3 plus 2, 5. Now, let me recap what I said before. Anytime you have an answer that is up to the base, you have to subtract. You must not have an answer that is up to 5. You can have an answer from 4 down. But once it is 5, even if it's 5, the base itself, you can't have 5 here because that's the base you're working with. So if you have 5, just like what we are having here, 1 plus 2 plus 2 will give us 5. So we are not going to write 5 here. No, you put down your 5, you are minusing the 5, which is the base from 5. So when 5 minus 5, the answer is what? 0. So it is 0 that you have here. Okay? So We go to the next one. Remember, this minus 5 that you subtracted, you carry it as 1 to this other part. Don't forget that. So here is 2 plus 1, 3. 3 plus 4, 7. 7 plus the 1 we carry, this minus 5 that we subtracted once, we take it as 1. That will give us 8 altogether. So here we have 8. Remember also, you can write 8 because 8 is bigger than 5. So you also have to subtract 5. We say 8 minus 5, and that will give you what? 3. So it's 3 that we have here. Now we also carry minus 5. So that minus 5, we'll take it as 1 and put it here. Now I will add 1 to here, say plus 1. This one also plus 1. So when we add 1 to this 4, it will also give us 5. Now we can write 5 here as well. So you subtract 5 minus 5, and that will give us what? 0. So you write 0 here. Then this minus 5 that you carry as 1, there is nothing there again. So you bring it down and write it here. So our answer is 1030 base what? 5. Okay, let me recap it. Now we are adding 421 plus 12 plus 42. Note that when you are adding, your answer must not be a number that is up to the base you are working with. And we are working with base 5. So our answer must be from 4 down. Once you have an answer that is 5 or more than 5, you subtract the base from it. It's the remainder that will be your answer. Okay, so we have 1 plus 2, 3, 3 plus 2, 5. 5 is the base we are working with, so we can't write 5 here. Rather, you subtract the base from the 5. This is the 5 we got as our answer, minus the base we are working with, and we are having 0. So it's 0 that you put here. Okay, now this minus 5 that you subtracted, we carry it as 1 to the next part. That's this plus 1 you are seeing here. So you add everything together. 4 plus 1, 5, 5 plus 2, 7, 7 plus this one, that will give us 8. Now you can't write 8 here. You subtract 5 from the 8, giving us 3. So it's 3 that you write here, which is the remainder. And this minus 5 is subtracted, you also carry it to the next part as 1, which is this plus 1 you are seeing here. Okay, so 4 plus 1 will give us 5. You cannot also write 5 here, just like the one we had first one. So you have to subtract 5 from 5 to give you 0. You write 0. Now you carry 1 again. The 1 5 you subtract and you carry it again. But there is no other number here to add it to. So you bring the 1 down at the back of the 0. So our answer is 1030 base 5. Okay. So let's take one more example. This one is a little bit different from what we have been doing. Example 7. The question says evaluate 99 plus 66 plus 48 in base 12. Evaluate 99 plus 66 plus 48 in base 12. Okay, solution. We have 99 plus 66 plus 48. The row. Okay, now I know that when you see this T, you'll be wondering, why is T there? Okay, in binary numbers, addition or subtraction or multiplication, anytime you see the letter T, T stands for 10. There are 2 letters that are being used. Use T and use E. T stands for 10, E stands for what? 11. Okay, so by the time you multiply or you add any binary number and you're having answer as 11, you write it as E, not 11 in the number. Okay, so this T here you are seeing means 10. So when we are adding, know that this T stands for what? 10. Okay, so let's add. Remember, we are working in base 12. So 9 plus 6 plus 8 will give us what? 9 plus 6 is 15, right? 15 plus 8 will give us 23. So we are having 23. But remember, we are working in base what? 12. So we are going to subtract 12 from 23. So we have 23 minus 12. So 3 minus 2 is 1. 2 minus 1 is 1. So our answer is what? 11. 23 minus the base, which is 12, is equals to what? 11. Now, like I said, you are not going to write 11 here. Rather, you write it as E. So what we have here is E. Okay? Now, let's go to the next one. Remember, this minus 12 that you carry, you take it as 1 to this other side. So you'll be having plus 1 here. Okay? Plus 1 is there. Now, this 10, this T stands for 10, like I said. So we have 10 plus 6 plus 4. 6 plus 4 already is 10. Plus this T, which is 10, is 20. Plus this one, that is what? 21. So everything here is giving us 21. So minus our 12 again from it. Okay? So 21 minus 12, let's do that. 21 minus 12. 2 minus 1 cannot. You borrow 1 from here, add to the 1 to give us what? 11. 11 minus 2, that will give us 9. 1 minus 1 is 0. Okay, so 21 minus 12 is what? 9. Now this 9, you can write it here because 9 is less than the base. So our answer here is 9. Now, the last thing is, we subtracted one base, so you will also take it as 1 to the next part, which will give you plus 1. And 9 plus 1 will give us what? 10. Like I said, you don't write 10, rather you use the letter T. So here is T. So our answer is T9E, base what? 12. I know this one is a little bit complex, so let me go through it again. Now, when you see a question like this, don't be confused. Most students will say, why is it T? Maybe it's a typographical error. No, it is not a typographical error. Anytime you see T or E in binary number, T stands for 10, E stands for 11. Okay? So when you see something like this, just arrange it and do your normal addition. When you add this, 9 plus 6 plus 8, that will give us 23. Like I said, you cannot have an answer that is bigger than the base. So you have to subtract the base, which is what? 12. So 23 minus 12, the answer is what? 11. Now this 11, you can't write 11 here as 1, 1. No, it's wrong. Rather, you replace it with the letter E. So that's this E you are seeing here. Okay? Now that minus 12 you subtracted, you take it as what? 1 and add to the next part. So here is our T. T is 10, like I said. So 10 plus 6, 16 plus 4, 20. Plus this one that you carry from this side, you're giving us what? 21. Okay, so 21, you can't write 21 here because it's also bigger than the base. So you have to subtract the base, which is 12, from 21 to give you what? 9. Now this 9 is what we have here. Now remember also this minus 12, which is 1, you carry it to the other side, and that will give you 1 plus this 9. So you have 1 plus 9, that is what? 10. Now this 10, you write it as T, not 1 and 0, no. Write it as what? T. Okay, so our answer is T9E base 12. I repeat, T9E base 12. Now if somebody should ask you what is T, T stands for 10, what is E, E stands for 11. So when you see this question like this, you should be able to know what this T stands for, and you should be able to know what E stands for. Look at the meaning here. T is equals to 10, E is equals to 11. It's just like the first letter of the spelling. T-E-N, 10, T for 10, then E for 11. Alright, so that is that for example 7. So let's quickly take assignments for today. Evaluate the following in their different bases. Evaluate the following in their different bases. Number 1, 423 plus 124 in base 4. Base 4. Then number 2 is under subtraction. 405 minus 217 in base 8. Alright, so these two questions is your assignment. Solve it and submit it in the comment section. In our next class, we also look at the correction of it.
Action.
Okay, so today we did the addition and subtraction of number base. We did about 7 examples under addition and subtraction of number base. So what I want to let you know is that anytime you are doing addition of number base, just know that when you add two numbers and it's bigger than the base you are working with, just subtract the base from the number. Then it is the remainder that will be your answer. Don't forget that. And in the next one, you are going to carry that number that you subtracted as 1 to the next part. And don't forget to add it, because if you forget to add it, you will not get the correct answer. So when it comes to subtraction of number base, it is a situation whereby when you see a number that is smaller than the down one, that's the one you want to subtract from, is smaller, then you have to borrow. In a normal addition, normal subtraction, what you borrow, you regard it as 10. But in the case of binary numbers or number base, what you borrow the base. Okay, so if you are working with base 8, when you are borrowing, you borrow 8. You borrow 1, but that 1 is regarded as 8. That is the rule. Okay, so when we talk about binary numbers too, in addition of binary numbers, 1 plus 1 is 10, not 2, like normal numbers. Okay, and 10 plus 1 is 1 in binary numbers, because anything you have to do under binary, you must have a binary number as answer, because binary numbers are numbers that consist of 0 and 1, is no more than that. So that is that for today's class. Please, this is your assignment. It's very important to do assignment because it will help you to know if you are following up. Okay, so try and do this assignment and submit it in the comment section. In our next class, we'll do the correction of the assignment. Thanks for watching. See you in our next video. Bye.